Alright, so in this video, I'm going to solve the equation x to the power of x to the power of 5 is equal to 100. So to solve this, I'm going to start off by taking the power of 5 on both sides. And now if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So x to the power of x to the power of 5 to the power of 5, I can switch the places of 5 and x to the power of 5. So I get x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. From here, I can rewrite 100 as 10 squared to the power of 5. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5 turns into 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, this turns to a equals b. So I get x to the power of 5 is equal to 10. And now if I take the fifth root on both sides, I get x is equal to the fifth root of 10. So this is my solution to this equation. Thank you guys for watching. Please make sure to subscribe and leave a like. Bye. Alright, so in this video, I'm going to solve the problem 32 to the power of 200 minus 2 to the power of 999. So to solve this, I'm going to first rewrite 32 as 2 to the power of 5. So I get 2 to the power of 5 to the power of 200 minus 2 to the power of 999. And this turns into 2 to the power of 1000 minus 2 to the power of 999 because the 5 and 200 multiply. Now to solve this, I'm going to rewrite 2 to the power of 1000 as 2 to the power of 99 plus 1. So I get 2 to the power of 999 times 2 to the power of 1 minus 2 to the power of 999, which is equal to 2 to the power of 999 times 2 minus 1, which is equal to 2 to the power of 999. Alright, so in this video, I'm going to solve the equation 1 to the power of x plus 10 to the power of x is equal to 100 to the power of x. So, to solve this, I'm going to first start by rewriting this as 1 to the power of x plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, I'm going to look at the term 1 to the power of x. Well, let's say we have 1 to the power of any number, like 1000. This is still equal to 1. And even if we have 1 to the power of infinity, this is still equal to 1. So no matter what value x could be, it's still going to be 1 to the power of x will still be equal to 1, meaning we can just ignore the x and just say this is 1 plus 10 to the power of x is equal to 10 squared to the power of x. Now from here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And a to the power of m times n is the same thing as a to the power of n times m. Well, if these two are the same, and a to the power of m times n is equal to a to the power of m to the power of n, this should mean that a to the power of n times m is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So, for 10 to the power of 2 to the power of x, I can switch the values of 2 and x. So now I get 1 plus 10 to the power of x is equal to 10 to the power of x to the power of 2. Now from here, I'm going to let 10 to the power of x equal to the variable y. So if I substitute in y for 10 to the power of x, I get 1 plus y is equal to y squared. Now I'm going to subtract y and 1 on both sides. So I get y squared minus y minus 1 is equal to 0. Now, what we have here is a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, I'm going to look at the coefficients. A is 1, b is negative 1, and c is negative 1. So I get y equals negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1. And now this is equal to 1 plus or minus the square root of 1 plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So I get that the value of y is equal to 1 plus or minus the square root of 5 over 2. However, we aren't done yet, because remember, we're solving for the value of x and not y. And we let 10 to the power of x equal to y. So I get 10 to the power of x equals 1 plus or minus the square root of 5 over 2. Now, this gives me two equations. I get 10 to the power of x is equal to 1 plus the square root of 5 over 2, and I get 10 to the power of x is equal to 1 minus the square root of 5 over 2. So I'm going to first start with 10 to the power of x is equal to 1 plus the square root of 5 over 2. Well, to solve this, we want the x over here, which is an exponent, to turn into an actual term. And to do that, we're going to use logarithms. So I get log 10 to the power of x is equal to log of 1 plus the square root of 5 over 2 when I take the log on both sides. And now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So I can move x here to the front, and I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. Now, I'm going to divide both sides by log 10 because x, we want to isolate x. So these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. Now, if you already didn't know, log 10 is equal to 1. So x is simply equal to log of 1 plus the square root of 5 over 2. And now the exact value of this is 0.209. So this is one solution of x. However, don't forget that we have the equation 10 to the power of x is equal to 1 minus the square root of 5 over 2. So to solve this, we're doing the same thing. We're going to be using logarithms. So I get log 10 to the power of x is equal to log of this time 1 minus the square root of 5 over 2. Now I can move x down, so I get x times log 10 is equal to log of 1 minus the square root of 5 over 2. And we don't even have to divide both sides by log 10 because we already know log 10 is equal to 1. So we can just get rid of it, and I get x is equal to log of 1 minus the square root of 5 over 2. Now, the log of 1 minus the square root of 5 over 2, the exact value of this is actually going to be negative 0.209 plus 1.364i. So there is an imaginary number in this. So this is my second solution to this equation. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends or family. Thank you.